Hello, welcome back. We're still in Unit 4, moving on to lesson number 8. So, surprise, surprise, we're going to do more calculations today. Again, this unit is very, very, very heavily math-based, but you're doing a great job so far. So, today we're going to talk about multi-step mole conversions. It's basically we'll get to it in a few slides. So, last video we talked about mole volume conversions. That was my personal favorite because I thought it was the easiest. We're going to review all of them shortly. Today we're going to work on multi-step mole conversions, and I'll show you what that means first. But let's revisit, lesson number 2. We first introed dimensional analysis, and I posed this question for you. How many days will it take to reread the Harry Potter series if I read continuously, meaning nonstop? And I told you that there were 4,224 pages in the books. I read 300 words per minute, and there are 367 words per page. So I did tell you that this was a more difficult kind of dimensional analysis question, but it's not multi-step question. So go ahead and try this again, and then we'll see how you did. Okay, so if we're looking at this question, good place to start is that there are 4,224 pages. So that will be our starting point. And so, knowing what we know, we want pages to go away. And the next thing about pages is how many words there are per page. So on one page, there is 367 words. So right now, our pages cancel, and we're in our unit words. We want words to cancel, so we're going to put that on the bottom. What conversion factor do we know next about words? Well, that, I can read 300 words in 1 minute. Now, I actually don't know if that's a lot or a little. I googled average word reading speed. I don't actually know how many words I can read in a minute. Doesn't matter though. Okay, now we're left in minutes. So we're going to go from minutes. We want that to cancel. We can't go directly from minutes to days, but we can go from minutes to hours. So in 1 hour, we have 60 minutes. Your minutes cancel. And then we can go from hours to days. In 1 day, we get 24 hours. And so that's 4224 times 367 over 300 times 60 times 24, which is 1550208 divided by 43200, and that is 3.59 days. Okay, so that is a very long 4-step conversion. So the max you'll see in chem, as of right now, is a 2-step. So if this makes perfect sense to you, fantastic. If not, it's okay. So here we are at Grand Central Station. If you've ever been to Grand Central Station, you know it is super busy. If you haven't been there, it is super busy. It's an iconic place in New York City. So you have the LRR from Long Island coming in. You have MTA from Westchester. You have is Amtrak New Jersey, whatever New Jersey's train. I think that's PATH. I don't know. Anyway, you have all these different trains coming in. Now, if I wanted to take a train from Long Island to, let's say, Westchester, I can't. I can't take a direct line. I have to go from my station to probably Jamaica, and then Jamaica to Grand Central, and then Grand Central to wherever. Grand Central acts as that meeting place for everybody. In order to get from one place, you have to go through Grand Central. And so, what I like to say is mole central station. So if we're going to convert between mass, grams, mass, volume, and particles, these are not connected to each other. So what we have to do is kind of go to moles and then go to something else. So, for example, if I wanted to go to mass, if I was given mass and wanted to go to particles, they're not connected to each other. What I would have to do is go from mass to moles, and then from moles to number of particles. So that's that two-step conversion. So let's kind of recap what this is. So this acts as a great resource for kind of like a cheat sheet for all these conversions. So if we're given mass, we are going to 1 mole and divide by the molar mass. If we're going from moles to mass, we are given mole over 1, going to multiply by the molar mass. Just like that. Okay. Next, if we're going from volume to moles, if we are given volume, we are going to divide by 22.4 liters, like that. But if we are given moles, we are going to multiply by 22.4 liters. I'm going to use that conversion factor. So whatever you're given, then you can just kind of plug in. And then lastly, if we're talking about number of particles, the given number of particles, we write part over 1, and we are going to divide by 6.022 times 10 to the 23 particles. If we are given moles, we are going to multiply by 6.022 times 10 to the 23 particles. So those are kind of your 6 conversion factors for the 3 conversions. Again, that's really just the one slide recap of the 3 videos on one slide. Remember, demo, you're dividing when you're going into moles and multiplying by your conversion factor when you're going out of moles. So that's there if you want. Great kind of thing to have in front of you. So if we're going to do this question, how many liters are in 806.895 grams of PCl5? So you want to go from liters to grams. Now, the problem is we can't go directly from liters to grams. What we're going to have to do, that doesn't work. You have to go from liters to moles, and then from moles to grams. So that's where that extra step comes into play. And so let's go ahead and do that. Our first step is going from ILAD. Okay, so if we're looking at this question, how many liters are in 806.895 grams of PCl5? It says we want to go from grams to liters. Now, the problem is we can't do that. We can't go directly from grams to liters. What we have to do instead is go from grams to moles, and then moles to liters. So that's where that extra step comes into play. So here we have 806.895 grams. Now we have to go from grams to moles. So grams is going to go on the bottom, moles is going to go on top in 1 mole. Well, what goes there? The answer is the molar mass. So if we're going to calculate the molar mass of PCl5, got to do that quickly. PCl5, P, we have 1 of them, mass is 31. Cl, we got 5 of them, the mass is 35. 31 plus, oops, I didn't do this one, 5 times 35 is, finding the calculator, here, 5 times 35 equals 175. 175 plus 31 is 206 grams per mole. So we have to take that little sidetrack to figure this out. 206. Now, our grams canceled and we're in moles. But that's not where we want to end up. We want to end up in liters. So we have to do another step. We want moles to go away. We want to end in liters. And we know in 1 mole, we have 22.4 liters. So now your moles cancel, and we're left with liters. That's where that multi-step comes in. So with this, you have 806.895 times 224 divided by 206, which gives you 87.7 liters. And that's it. So all we did was going from grams to moles and then moles to liters. I think just figuring out your path first, that's the hardest part. Because you guys at this point can do all these conversions. It's figuring out what path you should take to get there. Okay, so next, what is the volume occupied by 40 grams of argon gas at standard conditions? So if you have 40 grams of gas, you want to go from grams to liters. Can't do that. So what we have to do is go from grams to mole and then mole to liter. Now, we are given 40 grams. So that is our starting point. 40 grams over 1. So we want grams to cancel. Our next stop is moles. And so in 1 mole, we have to figure out what goes in this blue box. And that is the molar mass of AR. AR is just the element, so we don't need to do any fancy calculations. And so argon has a mass of 40 grams. That is it. So now our grams canceled and we are in moles. Now we're not done because we want to figure out the volume. So now we're going to go from moles, cancel that out, and go to volume, which is liters. In 1 mole, you have 22.4 liters. Your moles cancel out, you're left with liters. And so there is your 2-step question. So now you get 40 times 22.4 divided by 40, which gives you 22.4 liters. And that's it. Again, that's how the multi-step questions would look. When we're talking about mole conversions at this point, you only see these 2-step ones. Okay, let's do one more. There are 25 grams of glucose in a cup of hot chocolate. How many glucose molecules is that? So, this is kind of a fun type of question. If you've ever drinking hot chocolate, I was drinking it when I was making this question. How many molecules of glucose did you ingest? Kind of interesting thing to think of. So we're talking about grams, and we want to go to number of molecules. Now, we can't do that directly. That doesn't work. What we have to do, we have to go from grams to moles, and then from moles to number of particles. Again, adding that extra step. So what we do know is that 25 grams, that is our starting point. And we want to go from grams to moles first in 1 mole. And then in this green box is the molar mass of C6H12O6. Now again, because I am mean, I did not give that to you. So let's go ahead and calculate that. We have CHO, 6 C's, each of which is 12. 6 times 12 is 72. Plus our H's, we have 12 of them. Each is 1. 12 times 1 is 12. Plus our oxygens, we got 6 of them. Each has a mass of 16. 6 times 16 is 96. 72 plus 12 plus 96 is 180 grams per mole. Okay, so that goes right there, 180 grams per mole. Now, our grams canceled out. We're in moles, but we're not done yet. We want to get to number of molecules. So what we need to do next is go for moles number of particles. So in 1 mole, we're going to particles, or let me say molecules, because that's what it says in the question. Molecules, there's 6.022 times 10 to the 23 molecules in 1 mole of something. So now that we have all that set up, we're left with 25 times 6.022 times 10 to the 23rd divided by 180. When you plug it into a calculator, you have 8.4 times 10 to the 22 molecules. So, if you have a glass of Swiss Miss hot chocolate, that is how many molecules of sugar you just ingested. So, that is an interesting way to think about things. Okay, so that's it for this. We're going to practice again, like always, in class with more questions. But that's it for now. Next time, we'll talk about molecular and empirical formulas, what they are, how to calculate them, and all that other fun stuff. And that is it. Have a wonderful day.